this is a problem you may not think about using a conversion factor to solve, but it's an important example where you can. If you look at this and you think about using this equation, it may not be as simple as you think because the units don't match up. In other words, there are two units for volume and they're not the same. Milliliters and kiloliters are not the same. Same thing with the mass. So using that equation would be pretty complicated to handle all those units. So it could be done, but I'm going to show you the conversion factor way. So this one's more complicated to figure out where to start and what to put in that first box. This one's going to be kind of longer. We have two numbers given. And if you pay attention, this one actually has two numbers. It has the 0.78, but there's an implied 0.78 kilograms per 1 kiloliter. Okay, so which number do we put in the first box over here? Well, we put the 2.5 grams. And how did I know that? Well, remember, if you have a choice, use one number, one unit here. This one is not one number, one unit. It actually has two numbers and two units. So save that. That will be a conversion factor later. Okay, so I use this number. I know I'll put grams down here because I want it to cancel. And then I have to figure out, well, what am I going to put up here? What should I go to next? And so here's my hint. I'm going to be using this eventually, and this has kilograms in it. So if I can get to kilograms, then I will be able to use this conversion factor to get to volume. And so I'm going to convert to kilograms first. That will make my grams cancel. On my next step, I'll want kilograms down here because I'm going to try to get rid of kilograms. And now I'm ready to use this as a conversion factor. I need to make sure that the 0.78 goes with the kilograms. It always goes with the front one, and then this one will have the 1. Okay, so I'm going to put the 0.78 down here. And then up here I'm going to the kiloliters, and there will be a 1 there. So that's where I got this conversion factor, was from that. Okay, and I've done a lot of work. I've used all my given numbers, so I might think I'm finished, but check. My answer asks for milliliters, and this is not in milliliters. So I'm going to do some more steps. I'm going to put kiloliters down here because I want to get rid of it. And without thinking really hard, I don't know how many kiloliters in a milliliter, but I do know how to go to the base unit. And that gets rid of, I got rid of my kilograms, that gets rid of kiloliters. Now I need to get rid of liters, so I'll put it down here. I'm trying to get to milliliters, so I'll put that up there. And like so. So when I put this in my calculator, I get 3205, something like that. And this again is what the calculator says, but I need to think about significant figures. And so when I consider sig figs, I look at all of these numbers, and remember, if they're exact, they don't matter for sig figs. Anything that's a metric to metric conversion factor, those are exact by definition. Looking at other things, I have my given number here had 2 sig figs. And also this density is not an exact number. It has 2 sig figs. So it looks like I need 2 sig figs for my answer. And there are 2 different ways that you could write this number with 2 sig figs. You can write it either, well, first of all, do not write it this way. That's just totally changing the number. Occasionally people do that without thinking. But the way I prefer you to write it is to put it into scientific notation. And this is in, what are the units? Milliliters. The other way you could write it that's acceptable is like this. And the reason that I hesitate on that one is that it almost looks like an exact number, doesn't it? It looks like those digits are known. And so if you're a chemist and you know, it's not. But anyway, I prefer this one, but technically that one's okay as well. And I would take that on a test.